Now, good day, students.
Good day, sir.
Today we are still going to look at differentiation of inverse trigonometric functions. Last time we looked at the sine inverse. Today we are going to be looking at the cos inverse. I think the last time we talked about the sine inverse. Now today is the cos inverse. And we are going to be solving this. The same way, the same method we use in the first sine inverse is the same thing we are going to use to differentiate this. Now, we are going to say solution y is equal to cos inverse of s simply means y is equal to 1 all over cos of s. That is to say, if you have 3 inverse, simply means 1 all over 3. If you have 4 inverse, simply means 1 all over 4. That is the rule we did here. Now in this case, we are going to be timesing this. S times 1 is going to be S times 1 is S over cos. Now cross multiply. This is the cross multiply. This will carry this and this will carry this. That means cross product rule. Cross multiply. Cos times y is going to be what? Cos y is equal to 1 times s is going to be s. You can call this equation 1. Now we are going to be using what we call implicit differentiation to differentiate this. Now when we differentiate cos y is going to give us minus sine y. Since we are dealing with implicit differentiation, we are going to be having dy ds. We are differentiating cos with respect to y. Then we add this. It's equal to the differentiation of s is going to be 1. That is to say, if we differentiate s, we are going to be having s raised to the power of 1 minus 1, which implies that s raised to the power of 1 minus 1 is 0. S raised to the power of 0 is 1. Anything raising the power of 0 is 1. That is how we got this one. Therefore, we are going to be dividing everyone by sine y. We divide all through by sine y. We divide here by minus sine y. Also divide here by minus sine y. This and this cancel. We left with what? Dy with respect to s will be equal to 1 all over minus sine y. But in mathematics, we can't just put the negative at the denominator. We transfer the negative up now to the numerator. Now we're going to be having dy with respect to ds to be what? Minus 1 all over sine y. We can call this one equation 2. Therefore, in our trigonometric identity, we meant to understand that cos square theta plus sine square theta is equal to 1. Just as what we did in sine inverse, you saw it the other day. Now, in this case, we're going to make sine square theta the subject of the formula. That means this will come to this. And when it is coming, you change it with what? Negative. It's coming with negative. We're going to have sine square theta is equal to 1 minus cos square theta. Now, you are going to square both sides. When you square both sides, this one is having square. When you square both sides, a square is going to cancel this. You are going to be left with sine theta. Then, when you square it here, it becomes the square root of 1 minus cos square theta. When you square both sides, you square here, then the square is going to affect this to become this. Now, we are having this. Since we are working with the value of y, which our theta is y, you can replace this theta by y by saying sine y is equal to the square root of 1 minus cos square. Where you see theta, place y. Now, in our equation 2, from equation 2, we are having dy ds to be minus 1 all over sine y. And our sine y is given to be this. Let's just say this is equation 3. our sine y is given to be this. Wherever you see sine y, put this. Now we're going to be having dy with respect to ds is going to be what? Minus 1 all over root 1 minus cos square y. Now we have 1 minus negative 1 all over root 1 minus cos square y. Now our cos square y, our cos y is given to be what? S. Therefore you're going to have dy all over ds s to be what? Minus 1 all over root 1 minus, wherever you see cos y, you replace it with s from our equation 1, which cos y is s. And this is having cos square y. Then definitely s is going to be what? Twice. We're going to be having s squared. This becomes our final answer. In this case, therefore, y is equal to cos inverse of s is going to be giving us to be what? Minus 1 all over root 1 minus s squared. For the what? Differentiation of inverse trigonometric function. In our next class, we are going to be looking at tan inverse. In our next class, we are going to be looking at what? Tan inverse. Thank you very much. I still remain your boy, Mr. Ola.